All right, let's see. Okay, so it widens out. A narrow pipe widens out but goes downhill. Okay, so let's draw a picture of that. Narrow pipe widens out and goes downhill. It's all downhill. So this is 6.30 meters. This is a mere 5.10 meters. Okay, here it's going 4.10 meters per second. And it's a 3.5 centimeter diameter. Then it widens out, right? And then basically I think we got to figure out, I think what we're going to do is we're going to figure out the velocity here. And then we're going to figure out the diameter here. And that's what we got to figure out. Okay, here we go. So this is a Bernoulli. This is full-fledged, right? The first thing I want to do is, I guess, set up the Bernoulli equation, right? So pressure plus rho GH plus 1/2 rho V squared is equal to pressure plus rho GH plus 1/2 rho V squared. Okay, so our first pressure is 1.24 E5, and then we've got 1,000 times 9.81 times 6.3 plus 1/2 1,000 times 4.1 squared. That's our velocity, right? And then that's going to equal the new pressure, 1.4 plus 1,000 times 9.81 times 5.1 plus 1/2 1,000 times V squared. Okay. Okay. Yeah, okay, it's just a lot of stuff, right? So let's just start on this side. 1.24 E5 plus 1,000 times 9.81 times 6.3 plus 0.5 times 1,000 times 4.1 squared. And now I'm going to go minus 1.43 E5 minus 1,000 times 9.81 times 5.1 equals, and I've got 1177 equals 1/2 times V squared. So now I'm going to multiply by 2, divide by 1,000, and square root. And I get my velocity is, hey, I got the right velocity. This is a good sign. Okay, the velocity is 1.53427 meters per second. All right, now that we still don't have the diameter, right? So let's do the diameter. Let's do that right here. Okay, solving for the diameter. Right? Okay, so I'm going to use area times velocity is area times velocity. Now let me give you a clue. On the assessment, that's what it asks you to do. It just says, what's the diameter? And I give the clue, find the velocity first. So there it is. All of these full-fledged Bernoullis are going to have you do this part and then do this part. Now, in the other ones, in the other two types or whatever, where I ask you for height or pressure, you do this first. In this one, you do this last. Okay, so let's set this up. 3.5 centimeter diameter, that's this thing here, right? So this is pi times 0.035 over 2 squared times 4.1. That's the velocity, right? So area of this pipe right here times that velocity, right, is equal to times whatever that diameter is over 2 times 1.5. And don't round your, I'm actually going to use the value right out of my calculator here. Okay, so notice that pi goes the way of the bison. Notice that even divided by 2 goes the way of the bison. And so I'm going to start on, I guess, this side here. 0.35 squared times 4.1 divided by the answer that I just got. And that's going to be d squared. And then I'm going to square root it. And I get that the diameter is 0.05721 meters, which would be 5.72 centimeters. Look at that. This dog's gonna hunt.